Hi kids! Hey, I'm going to do a problem that is going to kind of encompass a bunch of different stuff from this unit. This is a pretty typical problem to see on the AP test, just because it does encompass a bunch of different stuff. So let me first set up kind of what's happening here. So I have a voltage source here. We'll just say it's 10 volts. It's hooked up to two parallel plates. Okay. The plates are separated by 50 centimeters. There is a ball, a metal sphere that hangs down. The metal sphere is going to have a mass of 9 grams, and it's hanging in equilibrium when this is at 30 degrees. And the question asked is, hey, determine the charge on the sphere. Okay, so that's what we're trying to do. So here's our kind of picture, what's going on. So it's like, well, geez, I don't know what to do. Well, yeah, you do know what to do. What do you always do? You start with drawing a picture. So in this case, what picture do you have to draw? Well, if you look, there's forces acting on this. So we should draw a force diagram, a free body diagram. So here is the metal sphere, and let's draw the forces acting on it. Well, you have the force of tension going this way, where that would be 30 degrees. Okay. You have the force of gravity going down. And then this thing is in equilibrium. So if you look the way it is right now, if I was to break this into its components, I would have a component that points this way and a component that points this way. Well, these two have to cancel each other out, but I have to have something that cancels this out. So there has to be some force going that way. Well, what is that force? That would be your electrostatic force. So then it would be like, well, geez, if you look, this is hooked up to the positive side of my battery. So this is going to be a positive plate. This is going to be a negative plate. Well, if the force is going that way, that means this charge would have to be a positive charge. So far, I know that it's a positive charge. I just have to then figure out how positive is it. Okay, so all right, so we did our first step. And then hopefully you guys see those two forces have to cancel. Okay. All right, so then we want to write our equations next. All right, so I'm going to write my equations. Well, I know that this side, I'll call this FT perpendicular, and I'll call this FT parallel. I know that FT perpendicular will have to be equal to FG, which means Fg is equal to mg, which, hey, that's 9 grams. I got to convert that to kilograms, and I multiply by 9.8. So I get that that is 0.009 times 9.8. I get that this is 0.0882 newtons. Well, that means in my triangle, 30 degrees, this side is 0.0882. Well, then let's use your mad trig powers and find how big the hypotenuse is, find how big this is. So if I divide by cosine 30, oops, I get this is essentially 0.1 newtons, and then multiplied by sine is going to be, this would be 0.05 newtons. All right. Then if you were to do your parallel one, well, that means FT parallel has to equal my electrostatic force. This is 0.05. So that is going to equal Q times E. But hopefully you remember, okay, that the electric field between two parallel plates, we had this equation, which was change in voltage over the separation. So if I do that, well, the change in voltage is going to be 10. The separation I want to convert to meters is going to be 0.5. So that's going to be 20 newtons per coulomb, or if you want, 20 volts per meter. Either one is totally fine. It's going to come out to be the same thing. Okay. And then if I plug that in, and then I do my math, 0.05 divided by 20, I get my charge is 0.0025 coulombs, so 2.5 millicoulombs. And then let's say, it doesn't ask this, but if you wanted to know how many electrons actually got transferred, you could then take 0.0025 and divide by 1.6 times 10 to the minus 19th. And if you did that, so divided by 1.6 times 10 to the minus 19th, you actually get 1.5625 times 10 to the 16th electrons were lost. Okay, because again, it was a positive charge. But just remember to do these problems, you're going to do your steps. Okay? Free body diagram, write your equation, and then plug stuff in and solve. Don't be lazy and skip steps. Do your steps, and it's pretty easy. All right. Bye, kids. Have a good day.